Civil 3D utilizes a number of types of settings. The drawing settings control the entire drawing. The object settings control the settings for an entire object, such as a surface or profile. And the command settings apply to just one specific command within Civil 3D. Start by looking at the drawing settings. In the tool space, Settings tab, at the top you can see your drawing name is in bold. It is important to remember that the active drawing name must be in bold. Bold designates that this is the current active drawing on your screen. If the drawing name is dimmed, that indicates it is a drawing that you open, but it is not the current drawing in your drawing window. You can change the drawing settings for an opened but not active drawing by right-clicking the dimmed drawing name. But be careful because you may confuse yourself thinking you just changed the settings for the current drawing. So make sure the drawing name is in bold. If not, then scroll up in the Settings tab until you find the bold named drawing. Right-click the drawing name and select Edit Drawing Settings. The Drawing Settings dialog box opens. There are 5 tabs in this dialog box: Units and Zone, Transformation, Object Layers, Abbreviation, and Ambient Settings. Start by clicking the Units and Zone tab. In the Units and Zone tab, you can set the drawing model units to either feet or meters, and you can also set the angular units. If your drawing model is set to feet, you can choose whether it is the International Foot or the US Survey Foot. Be careful here, because sometimes you need survey foot, and sometimes you do not. Ask your surveyor what they use to be sure you have set the correct units for your drawing. Or you can look at their survey drawing settings to see what they set and match their settings. Best practice is to get the zone information from them as well, so you can match that too. Along with the unit settings, you also have an option to set the drawing scale in this dialog box. You can also find the same exact setting in the status bar, where it is called the annotation scale. Change the drawing scale in this dialog box from 40 to 20 and then click Apply. Now look at the status bar and you can see that the annotation scale has changed to match what you set in the drawing settings dialog box. Back in the Units and Zone tab, under Zone, you can also set the coordinate system for your drawing. Here you have a list of thousands of coordinate systems from around the world. When you select a category, for instance, one of the USA state categories, you'll see a large list of coordinate systems inside each of those categories. Expand the categories, drop down and find the USA Mississippi zone. Then, under Available Coordinate Systems, select the NAD 83 East Zone US Foot. Click Apply, and now you have set your drawing zone to the east part of Mississippi and NAD 83 US Foot. Most of the time, you'll be working in NAD 83 in the US. In other parts of the world, you would be working in metric units, and whichever zone the country may be in. If you have no idea what the coordinate system of your drawing is, leave it set to no datum, no projection, until you find out what the zone should be. Lastly, on the Units and Zone tab are the options to scale objects inserted from other drawings and set AutoCAD variables to match. If you enable these, they can interfere with your insert commands for both blocks and XREFs. If you need to always scale a block 12 times up or down, or by some other common scale factor, then selecting the Scale Objects Inserted from Other Drawings is a good option. Otherwise, leave them deselected. On the Transformation tab, if you do not have a zone set, then none of these options are selectable. Until you set a zone in the Units and Zone tab, you cannot set any of the transformation settings. Since you have a zone, then the options in this tab are available. To understand the options on this tab, think of changing from a NAD 83 zone to a state plane coordinate system. This is what this tab is for. Sometimes the end result of your project must be in state plane coordinate system, but the survey that you received is in NAD 83. This is the area of the drawing settings where you could manipulate your drawing without having to physically move, rotate, and scale everything so that it changes from NAD 83 to the state plane coordinate system for your area. When you click Apply Transformation Settings, you are given the option to make adjustments for the datum or to apply a grid scale factor to your complete drawing. For example, you may need to rotate your drawing around a benchmark to get it to line up with what your client needs. In that case, you would use the reference point options to specify a reference point for that transformation. However, before you use these options, usually your surveyor can give you the information you need to convert your project to state plane coordinates. Take that information that they give you and enter it here. On the Object Layers tab, you can set the default layer that objects are created on. By adding a modifier to the prefix or suffix of the layer, you can place each object on its own individual layer. For ease of object management, it is recommended that you use set modifiers of -* or *# on the following layers: alignment, profile, tin surface, and tin surface - labeling. The asterisk option is the wildcard. By adding that modifier, whatever name you give the object is what will be placed in the wildcard spot of the layer name. For example, if the alignments are set to the C-road layer, and then you select to add a modifier of a suffix of -*, when you create your alignment and call it Street A, then the layer it will go on is C-road-Street A. Lastly, in this tab, you should always enable the immediate and independent layer on-off control of display components at the bottom. This gives you both object layer and style layer control of your objects when you are XREFing this drawing into another drawing. Also on the Object Layers tab, you can change the base layer name for any object by simply clicking the current layer name and then selecting the layer that is currently in the drawing from the Layer Selection dialog box. If the layer you need is not already created, then you can click New in the Layer Selection dialog box to create a new layer. By setting all of your layers on this tab for all the initial object placements, they become part of a template. Then you can save this drawing as a template file, and what you set here will always be set this way every time you open it. On the Abbreviations tab, all of the abbreviations found in the reports that reference alignment and profile data can be changed. You can set any of the abbreviations that Civil 3D will use. However, the defaults here are probably appropriate. If you have any special needs for the particular area in which you are working, you can change these abbreviations here and save those to the template as well. Lastly is the Ambient Settings tab. This is where you can set whether or not the event viewer displays and whether you can turn off your tooltips, as well as many other default drawing settings. You can also set specific settings for things like distance and how that is displayed in the drawing. For instance, the units can be set and you can see all the different unit options. Also, the decimal precision for display can be set, as well as rounding and how the negative sign will be handled. You can change any one of these values. Change the decimal precision to 4 decimal places. Once this is changed, it is applied to the entire drawing unless there is an override selected here, as you can see with this child override arrow. You could clear this child override by clicking this icon, which would force the value of 4 decimal places of precision onto all of the distances within the drawing. Click OK to accept the changes to your drawing, or click Cancel to close this dialog box. After spending some time making changes in the drawing settings dialog box, you can choose to make a template so that you can use these settings over and over. Start with the blank template that is given to you by Autodesk and not the example files for this course. To do that, save the changed drawing as a template DWT file, then map your options for templates to where this new template file is saved. That way, every time you click New for a new drawing, the updated template file with the correct drawing settings is always opened. It is good practice to create a usable template for all of your projects. Spend some time and configure your template drawing and the drawing settings to what would work best for you and your company. As you can see, Civil 3D has many in-depth controls for data.